Hello everyone, in this video I am going to teach how to insert a node into a doubly linked list. And see, first I'll teach you how to insert a node at the beginning of a doubly linked list. This is the given doubly linked list with two nodes. This is the first node having address 100, this is the second node having address 200. See, now you have two pointers, head and tail. Head points towards the first node, tail points towards the last node. Now see, what is the structure of this doubly linked list? It contains three parts. First part is called previous pointer, which stores the address of previous node. There is no previous node here, so it stores 0. And see, this is the middle part is known as data part, which stores the data value. And this third part is called next pointer, which stores the address of next node. Address is 200, so 200 is stored here. Same like that for this node also. See, so doubly linked list means there will be two links in forward direction and backward direction. Now see, let's see how to insert at the beginning of a doubly linked list. First, this linked list is not empty. Now first let's see the case when the doubly linked list is empty. So see here, I am taking two pointers, head and tail. Now see, there are no nodes present in the linked list. So head should point out towards the first node, tail should point towards the last node. But there are no nodes. If no nodes are there, means head value and tail value will be 0. So if these two values are 0, means you can say the linked list is empty. Now let's see in this case how to insert a new node at the beginning of a doubly linked list. See, first I want to create a new node. See, this is the first step. I have to create a new node of this structure which contains three parts. Now see, let's say the address of this node is 10. So how you should access this new node? How to access? You need a pointer. So I am creating a pointer called new node. And this pointer stores the address of new node, that is 10. So it points towards this node. Now see, first step is what? I will write the code simultaneously. First step is you have created a new node. How to create that new node? You can create dynamically by using malloc function. So I am creating it. See here. New node equals to struct node star malloc size of node. Now see, now you have created this node by using malloc function, and the size of node is what? It contains three parts. Each part stores the integer value. This pointer stores integer value, that is the address of previous node. So integer value takes 4 bytes. So this is 4 bytes, this is 4 bytes, this is 4 bytes. So 4 into 3, 12 bytes. That is the size of node. Now see, I have created a new node. Now I should ask the user to enter the data into it. So I am writing see, printf enter data. Now let's say suppose the user enters 7. So 7 should be stored into the data part of new node. So the computer should read this 7 as the data part. How to read? By using scanf function. So I am writing scanf %d and new node data. This is the data part of which node? It's the data part of new node. So I am writing new node data. See, new node is 10. 10's data is here. So 7 gets stored over here. Now see, now the next step is you have created a node. Now you should make this as the first node and as well as the last node, because the linked list is empty. So the only one node which is present is this node. So this is the first node and as well as last node. So head points towards the first node, tail points towards the last node. So both are same. So 10 should be stored in head and tail. So I want to write that condition. See, what is that condition is? If head and tail is 0, that means when the linked list is empty. So I am writing see, if head equals to tail equals to 0, you can say the linked list is empty. Now this is the first node. Now I want to point head and tail towards this node. So see, I am writing the formula code. Head equals to tail equals to new node. I have written head and tail. See, head and tail is new node. What is the new node address? 10. So 10 is put on head and 10 is put on tail. Now head is pointing to the node which is having address 10. Tail is also pointing to the node which is having address 10. Now see, now I have created a node. There is only data part present, which should have previous pointer as well as next pointer. See, only one node is present here. So there is no previous node here and next node here. So previous pointer should point towards the previous node. So address of previous node, but no node is present. So I should write here 0. And here also in next pointer also I should write 0 because no node is present after this. So how to access this previous pointer? By using new node previous. So see here I am writing new node previous equals to 0. And so here 0. Now new node next is 0. Now see, new node is 10. 10 next is 0. Now you have created a new node, that is inserted a node at the beginning of a doubly linked list when the linked list is empty. This is the case when the linked list is empty. Now see, now let's see the case when the linked list is not empty. So I am writing the else condition. See, in this case it creates a new node. So see here, I am creating a new node. Now let's say the address of this is 10 suppose, and it asks the data to insert. Suppose the user says 9. So 9 should be stored into the data part using scanf function. So 9 is put here. Now see, now it checks this condition whether the linked list is empty or not. Whether head and tail is 0. No, head is pointing at 100 and tail is pointing at 200. So you can say more than one node is present here, because if head and tail are pointing to the same node means one node is only present, but head and tail are different. So you can say more than one node is present. So the linked list is not empty. So go to the else part. It does not enter into this condition. It goes to else part. Now see what to do. Now this is the next point. This head pointer should point towards this node. Now see. Now you want to have a pointer to access this node. So I am creating a pointer called new node. And this pointer stores the address 10. So this pointer points towards this thing. Now see. Now next thing is here this next pointer of this node should contain the address of next node. If you make this as first node and this as second node, so this pointer should contain the address of this node, that is 100 should be stored here. So how to get 100? You can get it from head pointer. So I am writing the code. See here. Else new node next equals to head. Now see what is new node next. New node next is next pointer. In this pointer I am storing head value, head address. Head is 100. So I am storing 100. So it creates a forward link in forward direction. It points to this node having address 100. Now see. Now I should point this pointer to the previous node. So I should have the address of this node into this. So 10 should be stored into this previous pointer of node 100. So how to get address of this node 10? You can get it from new node. So I am writing SC head previous equals to new node. Now see what is head previous. Head is 100. 100 previous is this part. In this part I am storing new node address, that is 10. So this pointer is pointing to the node which is having address 10. So it creates a link like this. Now see. Now this is the previous pointer of new node. In this pointer I should store the address of previous node, but there is no previous node here. So I should store here 0. So I am writing SC new node previous equals to 0. So new node is 10. 10 previous is this pointer. In this pointer I am storing 0. Now see. Now head should point towards the first node, but now this is the first node after inserting. So you should move the head pointer to here. Head should point towards 10. So head should store 10 value. So how to get 10? You can get from new node. So I am writing the code. See here. Head equals to new node. Now see, what is the new node address? 10. So 10 is stored in head. So this link gets cancelled and head is pointing towards this node. Now you have inserted a node. This is how you should insert a new node at the beginning of a doubly linked list. See, now I will teach you how to insert a new node at the end of a doubly linked list. First, let's see the case when the linked list is empty. See, now head and tail will be 0 because there are no nodes present in the linked list. So you can't point head and tail to any node. So head and tail are 0. So follow this same step again till this thing. See, now you are creating a new node. by malloc function. So see here, I'm creating a new node. Now I need to access this new node, so I'm creating a pointer for accessing this node. Let's say the address of this node is 10, so 10 is stored here, and this pointer points towards this new node. Now see, now I should enter data here. So it's asking to enter data. Let's say 8. So 8 is stored here. Now see, now I am checking whether the linked list is empty or not. That is, head and tail is 0. Yeah, head and tail is 0. So no nodes are present. So I should head equals to tail equals to new node. So head and tail should point towards this node. So what is the new node address? 10. 10 is stored here, head and tail. So this pointer head and tail points towards the same node. So this is the first node as well as last node. Now see, now next step is new node previous equals to 0. That means new node is 10, 10 previous, this thing, previous pointer. Here it's 0 because no node is present before this. Then new node next equals to 0. Now new node is 10, 10's next is 0. So no node is present after this. Now you have created a doubly linked list with one node, and there is no node, so there is no node present in left and right. This is how you should create when the linked list is empty. Same procedure. Now see, now let's see the case when the linked list is not empty. Now see, it checks whether the head and tail is 0. No, head and tail is not 0. So you can say there are more number of elements, more than one number of element, one node. So now see, now you want to create a new node. So I'm creating a new node. I should create it insert it at the end of a linked list. So I need a pointer for accessing this node. So I'm creating a pointer. Let's say this address is 300. So 300 is stored in this pointer. So this pointer points towards this node. Now see, now I want to store data. Let's say 8 is stored here. Now see, now I want to I have created a new node. Now I should make this as the last node. How I can make? See here, this is the next pointer which stores the address of next node. So this is the last node. So there is no node after this before inserting here. But so I have stored 0. But after inserting this node, at the end you should store the address of this node into this pointer part. So what is the address of this node? 300. 300 should be stored here. Where can you get this 300 from? You can get it from new node address. So I'm writing the code. See here, tail next equals to new node. Now see, tail is 200. 200's next is this pointer. In this pointer I'm storing new node address, that is 300. So this becomes 300. So this pointer is pointing to a node which is having address 300. Now see, now this is the previous pointer. In this previous pointer I should store the address of previous node. Now after inserting this at the end, what is the previous node? This will be the previous node. So what is this address? 200. 200 should be stored here. So where can you get this 200 from? You can get it from tail. So see here, I'm writing the code. New node previous equals to tail. Now see, what is new node previous? New node is 300. 300 previous is this pointer, previous pointer. In that pointer I should store the tail address. Tail address is 200. So I'm storing it 200. So it creates a backward link. This pointer points towards a node which is having address 200. Now see, now this is the next pointer. Now in this pointer I should store 0 because you are inserting this node at the end. So no node will be present after this. So I should write here 0. So how I can access this next pointer? By using new node next. So see here, new node next equals to 0. Now new node is 300. 300 next is here. Here I am putting 0. So no node is present after this. Now see, now tail pointer should point towards the last node, but it's pointing towards the second last node. So now it should point towards the node which is having address 300. So where can you get 300 from? From new node. So I'm writing here, see, tail equals to new node. Now new node is 300. 300 is put on the tail. So this pointer is getting cancelled and tail is pointing towards the node which is having address 300. So it's pointing towards the last node. This is how you should insert the new node at the end of a doubly linked list. See, now I'll teach you how to insert a new node after a given position in the linked list. See, Now you should ask the user after which position you want to insert a new node. So see here I am writing the code. Printf enter position. So the user enters some position. So that value should be stored in position. So how I can store? By using scanf function. So scanf function reads the value in as position value. So see here scanf %d and position. Now see. Now if suppose see in this example this is the doubly linked list. We are having 4 nodes here. Suppose if we are asking the user to enter position. So if the user says 5, that means after 5th position you want to insert. That means at 6th position you want to insert. So if you want to insert at 6th position means you need a 5th node present here. But there is no 5th node here. So you can't insert a node at that position. So see what is, you should write that condition. If see what is that condition? Now position is 5. 5 is greater than number of nodes present here. Number of nodes are count. So see here I am writing position greater than count. In this case 5 is greater than 4. 4 nodes are present. So see here to count the number of nodes in this linked list, it's a different program. I have taught you in the other video. You should check that video how to count the number of nodes present in the linked list. Now see here 5 is greater than 4. So it should print invalid. So print f invalid. Now see, now next condition else what you should do. See now it again asks the user to enter the correct position. So if the user enters 2, that means after second position you want to insert. So what is the first? This is first node, this is second node. So here is the third node. In between of this two you should insert. So what to do? I want to create a new node. So I am creating a new node. Now let's say this address is 150. So now see the user asks to enter data. Suppose the user says 7. 7 is inserted into the data part. Now see. Now this is the previous pointer. In this previous pointer of this new node, now you want to access this new node. How to access? You need a pointer. So I am creating a pointer called new node. So I am storing in this pointer this new node address 150. So this pointer is pointing to this node. Now see in this previous pointer, I should store the address of previous node. If you insert this node in between of this two, the previous node of this will be this node. So 100 should be stored here. Now how you can get this 100? Where can you get it from? There is no pointer pointing to 100. So you want to create a pointer. So I am creating a pointer called temp. Now see, temp can't directly point to this node. You can't directly point. For that in linked list you should start from, at first you should start temp pointer to point to first node. Then one by one you should move the temp pointer till temp pointer is pointing to node 100. So see here. Now temp is you have created a pointer called temp and it's pointing to the first node. So see here I am writing. Now you should stop at this 100. After this you should not move the temp pointer. So what is the condition? See here I am writing while I less than position. What is this I? I is a pointer. No, I is a variable which stores the which tells where the temp pointer is pointing to, at which node the temp pointer is pointing. See at starting I will be 1. Why it is 1? Because at starting temp is pointing to the first node, so I will be 1. So see now temp is equals to head because head stores the address of first node. So I am writing 10 into this. So temp is pointing to this position. Now see, now I should write the condition while I less than position. See, I is 1. So 1 is less than this 2. So you will move this temp pointer to next node. So how you can move? You should store the address of this node here. 100 should be stored. Where can you get this 100 from? From the next pointer of previous node. So see here I am writing temp equals to temp next. Now see, now temp is moved to next pointer. Temp is 10, 10 next is 100. So 100 is written over here. Now temp is pointing to the second node. Now see, Now temp is pointing to second node means I should be 2. So you should increase the I value by 1. So I am writing here I plus plus. Now see, 1 is updated to 2. Now go back to the same step and check again. While I less than position, I is 2. 2 is not less than this 2. So you should not enter into this step. That is, you should not move the temp pointer again one step forward. Now see, temp is pointing at this 100. Now in this previous pointer, this part, I should store the address of previous node. If you insert this node in between of these two, the previous node will be 100. So you should store 100 here. Now where can I get 100 from? From this temp pointer. So I am writing the condition. See. Now see, new node previous equals to temp. Now see, new node previous is what? New node previous is this pointer, previous pointer. In that pointer I should store temp address. Temp is 100. So 100 is stored here. So this pointer is pointing to the node which is containing address 100. Now see, this pointer, next pointer should store the address of next node. That is this node. So you should store 200 here. Where can you get 200 from? 200 is stored in the pointer, next pointer of temp node. So I am writing, see here, new node next equals to temp next. Now see, new node next is what? New node 150. 150 next is this pointer. In that pointer I should store the address of temp next. Temp is 100. 100 next is 200. So 200 I am storing here. Now this pointer is pointing to the node which is having address 200. Now see, now I have just created a single list, linked list. Now it should create a double linked list. So see, previous pointer of this node having address 200. In this previous pointer you should store the address of previous node. So if you insert this node in between, so previous node will be this. So 150 should be stored here. Now where can you get this 150 from? 150 you can get it from new node pointer. Now how to access this previous pointer? For this you should write 200 previous. Now for 200 where can you get it from? 200 is stored in the next pointer of previous node, in the new node. So see here, I am writing this. New node next previous equals to new node. Now see, what is new node next? New node is 150. 150 next is this pointer 200. Now 200's previous, 200's is this node. This node's previous is this pointer. In this pointer I should store new node address, that is 150. So see here, I am writing here 150. So it's not pointing to 100 anymore. No, it's not pointing to 100 anymore. So this link gets cancelled. Now this pointer is pointing to previous node, that is 150. Now see, now this pointer should contain the address of next node. So what if you insert this node, the next node will be this thing 150. So 150 should be stored over this pointer, next pointer of node 100. So how to do? See here. Now how to access this next pointer? You can access by temp next. In this temp next I should store the address of 150. 150 you can get from new node. So see here, temp next equals to new node. Now see, temp is 100. 100 next is this pointer. In this pointer I am storing the address of new node. New node is 150. So 150 is stored here. So this link is cancelled. And this pointer is pointing to the node which is having address 150. That is this node. So see, you have inserted this node at the after second position. So this is how you should insert a node after a given position. And that's all for today, and thank you. If you feel my teaching is good, then like my video, and if you have any doubts or if you want to give any suggestion, then comment on my video and share my video, and don't forget to subscribe my video. Thank you.